All right, you guys, here we go. It is the place value battle. Oh, yeah. We're going place value and we're going to battle it up. So here we go. Check it out. We have 437 in this first round versus 823. But did you notice I highlighted something in there? I highlighted some digits. This digit of the 3 is battling this 3 digit. Yeah, they're both 3s, but they're in different places. So the battle ensues. So let's try this one out. I'm going to grab my pencil or pen and I'm going to write, all right, what this 3 is worth. Well, that 3, if it's in that place, is worth not just 3. I'd have to convert that to a 0 because that's in the 10 spot. That's worth 30. Whereas this 3 is in the final spot. It's in the 1 spot. There aren't any other digits after it. So it's just worth 3. So in this case, 30 is greater than 3. Did 30 beat 3 today? Yeah, this 3 took the battle. But let's write something else about this. Let's get more mathy with it. Okay, so I'm going to type it out. You can write it out. 30 is greater. We know that, right? But let's extend it a little further. 30 is how many times greater than 3? How much bigger is 30 than 3? Because they were the same digits. It just got moved over in its place. So to figure this out, it's kind of nice to write an equation to help figure it out. So I'm going to compare 30 with 3. Now I know that they are not equal to each other, okay? But I'm going to use the equal sign and say, how many times do I need of the 3 to then hit 30? Well, what number times 3 gives me 30? Oh my gosh, that's a nice one. It's 10. That works out nice. 30 is 10 times greater than 3. 10 times as big. And all that happened was this 3 here was in the 10 spot, and this 3 was in the 1 spot. Weirdness. Okay, let's do another battle. Here we go, battling it out. What about this one? Now we don't have the digits of 3, now we have the digits of 2. And same idea here. This 2 is worth not just a 2. It is in the hundreds place. So I'm going to take these 2 digits out and convert them to zeros. This is worth 200. How about this 2 over here? Is that worth 200? Well, I have a 2, but it's in the tens spot. So I'm going to replace that with a 0, and it's worth 20. So yet again, the left side taking the win. But by how much? So I'm going to write out my sentence, and I'm going to say, okay, 200 is times, is it bigger? Yeah. So I could say bigger or greater than 20. What is it going to be this time? So if I write out my equation, 220, it's not equal. I'd have to multiply this by what to be at 200? And oh my gosh, all I need to do is attach another 0 to 20 and I'm at 200, which means I'm going to multiply it by 10. 10 times 20 gives me 200. So 200 is 10 times greater. Took the win. Okay, let's attempt one more. Okay, now we go from 3s to 2s to 8s. Is the left side going to win again? All right, we have an 8, but it's not just an 8. It's worth, put 3 zeros after it. It's worth 8,000. Okay, how about this 8? Is that only 8? No way, man. It's not at the end of the number. Gosh, it got really moved over. I'm going to have to put how many zeros after that? 4. 1, 2, 3, 4. Now I'm going to insert my comma. So I start at the back, go over 3. 1, 2, 3, comma. 1, 2, 3. Okay, that's the only comma. So I have 8,000 versus 80,000. Oh man, right side takes the win. Yes, we got a bigger number over here, but by how much? So I'm going to start by writing 8,000. That's where we started, right here. Is how many times greater than 80,000? Now hold on. It's not greater, is it? I'm going to have to change this to less. 8,000 is how many times less than 80,000? Oh gosh. All right, I'm going to write my equation to figure this out. 8,000. And I'm thinking, okay, it's not equal to 80,000. And if I multiply 80,000 by a whole number, it's going to get bigger. It's going to get bigger. So I actually don't want to multiply. I'm actually going to divide. That makes things smaller. And what am I going to divide 80,000 by so that I get 8,000? Well, I need one of those zeros to go away off to the 80,000. So I have to think in terms of multiplication. What does this problem actually mean? It means, if I think backwards, 8,000, right here, times what, that's right here, will give you 80,000. So we can actually think of it as a multiplication problem. We just have to turn it around. And what do you know? Who comes into play yet again? The number 10. 8,000 times 10 will give us 80,000. So 8,000 is 10 times less this time than 80,000. Awesomeness. All right. There are some practice problems for you to do. I don't write the number for you right off the bat. I write it in words so that you have to practice writing what is that as a number. So like 2,204, how would you write that up here? Well, I know here's my 1,000. I have 2 of the thousands, and then I have 204. So 204, that would be 240. So I would need to put a 0 here and the 4 here. Okay? And then I'm going to write my other number, and I'm going to battle it out and compare them. I'm going to write an equation to help myself figure it out and write how many times greater or less. You're going to have to circle one of those, right? Okay, so all together, we have our place value chart. And what we did is we took certain digits, right, and we battled them out together. So I'm going to move around this 3, and I'm going to start here in the ones. If this digit 3 gets moved here, what happened? It's 10 times greater. 10 times greater just because we moved its place over. What if I move it over here? Now this 3 is 10 times greater than what it just was. Okay? Now what if I go the other way? What if I move this 3 this way? Now it becomes less. How much less? Well, what did we end up having to do? We had to divide by 10 to get it over here, which makes it 10 times less as it moves this direction. So that's really cool with the place value chart, that it has everything to do with powers of 10. Oh yeah!